Welcome to Excel Business Statistical Analysis, video 9 to 16. Yeah, this is chapter 3 where we study descriptive statistics, but now we're going to study numerical measures. Video 9 will study measures of central location. Video 10 and video 11, both measures of central location. Then in video 12, we'll study percentiles and quartiles, which is all about location, but not always in the center. Then we'll study one of the most important topics in statistics, variation. In particular, we'll learn all about standard deviation. And then in video 14, we'll talk about relative location and the amazing z-score and the theorems and rules that go along with it. And finally, we'll close it out with the famous 5-number summary. Now, in the folder that you created in video 1 with your name, you should now have chapter 3. Excel file and the CPA score, which we'll use in video 15. Now here's the topics, video by video. Here's the notes sheet. Remember, in all these workbooks, if you Control P, I've already done the page setup, and there are 9 pages of notes, including all the formulas. And now on the sheet location, this is where we're going to start our fun with chapter 3, numerical measures. Now, what is location anyway? Location locates or positions a data point. For example, your score of 85 on a particular test. It locates that data point against the full data set. So for example, here's all the scores. And we can locate using the mean calculation, percentile, or even z-score. But a simple example is, if you ask the question, are you above average? What you're doing is locating yourself, the score of 85, against a typical value, or a value that has a central tendency, or one that is near the middle of the data set. Now, the mean calculation adds up the numbers and divides by the count. And in Excel, we use the average function. You can see returns the average, arithmetic mean, tab. If I highlight all the numbers and hit Enter, there's our typical value, or our mean calculation, or our measure of central tendency. So to answer the question, are you above an average of 69? Yes, in fact, you are way above average. Now, the mean calculation is only one way to calculate an average. And sometimes the mean is right in the middle of the data set, where about 50% of the values are above and 50% of the values are below. But if you really want to measure positionally the exact center point in the data set, that's where the median calculation comes in. If the data set is sorted smallest to biggest, and this data set actually has 21 values. So if we counted down 10 values and then up 10 values, this is an odd number count. So that 68 is exactly the marker of the middle of the data set. We could say about 50% below and 50% above. Now, we don't have to sort and manually make the median calculation because there's a function called median. We simply highlight, and when I hit Enter, I have a second measure of central location. And this one actually marks the middle of the data set. Now, those are markers of central location. Sometimes we don't want the middle. We want a 75% marker. That means where in the data set can we say about 75% below and 25% above? Now, just like the average calculation, percentile has multiple ways to make the calculation. We'll learn about the algorithm for both of them. For the time being, I'm going to use that top one, .exc tab. I simply highlight the array, comma, and the k. That's some number between 0 and 1, 75% for us. And when I close parentheses and hit Enter, that's the marker in the data set. Now, that particular marker isn't even in this data set. But if we were to imagine right between 78 and 84, that's the marker that says about 75% below and 25% above. So if we're locating your score of 85, you're way above average, and you're above the 75th percentile marker. Now that's an introduction to location. Our next task is to talk about measures of central location. And we want to go over to the sheet mean, population, or sample. Now one of the most common measures of central location is mean. Oftentimes we just refer to it as an average. This is a typical value calculated so that we can have one value that represents all the data points. Now the formulas that we use for mean, add them up, divide by the count. They're exactly the same whether or not you have sample data or you have population data. But we use different variables. If it's sample data, we refer to the mean calculation as x bar. I oftentimes will write it out just like that, x bar. And notice sigma means add them up. X sub I means all the particular x's. And then little n means the count. That's the count of the sample. For population data, we use the Greek letter mu, like a cat, mew. But we do the same calculation. Sum all the particular x's, but now we divide by big N, which represents the count of the population. In either case, in Excel, we use average. So I'm going to calculate a population parameter. This is a calculation or a measure made on population data. So mean, or mu, is $10.87. Over here, I'm going to calculate a sample statistic. And I'm going to use the same function, average. Notice I color-coded the sample I took from population data. And hopefully, it'll be close. Now, the sample statistic, sample mean x bar of $11, is the point estimate. That means it's like it's pointing to and estimating what the population parameter should be. It's the point estimate of the population parameter, population mean, mu. Now later in chapter 7, 8, and 9, we'll use our sample statistic x bar to estimate, and we'll determine whether the estimation of the population parameter is reasonable or not. Now over on the sheet mean, we know that the arithmetic mean is add them up and divide by the count. Now we'll see other types of central location measurements, but the mean is good for quantitative data when there are not extreme values. If you have extreme values, either too big or too small, that can make the mean look too big or too small. Think of a housing neighborhood where almost all the houses are in the $250,000 range. And then there's $1 million house. That would make the mean, if you calculate it, look too big. Similarly, if you have just a few really small values and the rest of them are big, that might pull the mean down and make the mean look too small. In either case, using the median function or calculation would be a better measure of central location. Now, we can think of our mean as an average calculation, a typical value calculated so that we have one value to represent all the data points. Now let's look at two examples, and we'll start with averaging or calculating the mean for some test scores. And now we can use this average to compare to our scores and gauge how well we did. And we can also use the average of 67 in discussions about the class's performance. Another great example for the mean calculation. Here we have a column of weights in ounces of salad being filled in a bag by a filling machine. So this is a manufacturing example. So we pulled a number of bags and weighed them, and here's the average. Now we can use this average or mean to help us estimate whether the machine is filling correctly. If the package says 10 ounces, does it seem reasonable that it's filling 10.18? Well, in Chapter 9, we'll do hypothesis testing and see if this mean is reasonable or not. And it will help us determine whether we should shut down the machine or fix it or keep running it. Now let's go talk about our next measure of central location, median. Now, median is an average, a typical value, one value that stands in for all the values. However, for median, we sort the values smallest to biggest, ascending, and then take the one in the middle. If the count is odd, then you take the one in the middle. Here's some salaries. Here's the sorted list, 10 above, 10 below. So there's an odd count, so we take the 1 in the middle. That's it. That's the median. If the count is even, average the middle two. So you'd literally have to come over and average these middle two. Now we'll start with our median example on these house prices. And I want to calculate the average or the mean first. So we'll use average. And these are not sorted, but the functions work whether or not the data is sorted. So there's the mean. 392,000 is the average house value. Now, let me show you how to do it the first time manually. I'm going to copy this over to the side just so I can leave that here. And then Control V. There's a bunch of ways to sort. You can go up to Data, and there's a A to Z. You can also right-click Sort, A to Z. Once we have the list sorted, you have to determine how many there are. And there's many ways to determine how many. I'm simply going to highlight the rows and look down in the status bar. By the way, if this isn't turned on, right-click, and you can check the aggregate calculations that you want to show up in the status bar when you highlight data. So it says numerical count 20. So I'm going to come down, and I'm watching. I see 10. Right-click, and I'll add orange fill. And then these will be yellow. I didn't have to add color. But those two in the middle, since there isn't a middle one, I could come over here and average. And that would give me the median. So that value right there is right in between the 193 and 198. And that value exactly divides the data set positionally. 50% below, 50% above. But of course, we don't have to do it manually. Microsoft has a great built-in function, median. It doesn't care if it's sorted or not. It'll internally sort it and take the 1 in the middle. And because there was an even number, it averaged the middle two. Now, if we look at the mean, 392,000, and the median is 195,000, that's a huge difference between these two different measures for central location. And that's what happens to the mean when you have a few extreme values. That's why the median is good for quantitative data when there are extreme values, big or small, like house prices and salaries. This median just seems like it more fairly represents the data points. That's why you hear real estate agents say, hey, here's the median house price for a particular neighborhood. Now, as a second example, here's salaries from an accounting firm. And there's 21 values here. So if we sort it smallest to biggest, it's exactly the one positionally in the middle that represents the median value. And in this case, we would say there's about 50% below and 50% above. If we calculate the mean using the average function, we get a mean salary of 161. If we calculate the median, well, it'll do the heavy lifting, the sorting, and finding the 1 in the middle, 109. Now, again, there's a big difference here. The mean is bigger than the median. This is not always the case. Sometimes we get a mean that's a lot smaller than the median. In that case, there would be some extreme small values pulling the mean down away from the median. In this case, the median gives us a more representative typical value to make our decisions. When the mean is larger than the median, it usually means that a few large values are pulling the mean up. Now we've seen two calculations for measures of central tendency. The mean, which is certainly the most common. The median, which is very important because when we have extreme values, the median gives us a measure that's not affected as much by those extreme values. But guess what? There's one other, and there's a bunch of others too, but there's one more really important, average. And it's really important because what do you do with this type of data? You can't calculate the mean. You can't calculate the median. Instead, you calculate the mode. And the mode is simple. It's the one that occurs most frequently. Now, sometimes you can get bimodal, which means there's two, or multimodal. That just means there's a tie between a few items for the highest frequency. Now, when we get a data set like this, the fastest and easiest way to calculate the mode is to create a pivot table. So with the single cell inside of our table, we go up to Insert, Pivot Table, or we use our keyboard, Alt-NVT. And I'm going to put this on this sheet on cell D16. Click OK. I drag Favorite Cola down to rows. Instantly, I get a unique list. I drag this text field down to values, and we get a count up at the top of the column. I type frequency, and there you go. A frequency distribution from last chapter is a fast and easy way to pick out the one that occurs most frequently. And it looks like Bloxy Cola with a count of 7, a frequency of 7. That's the mode. Now, sometimes we calculate a mode even on quantitative data. And there's two mode functions, so I'm going to show you both. And MODE.MULTIPLE or MODE.SNGL. If you use MODE.SNGL, if there's a tie, bimodal or multimodal, it only gives you the first one it bumps into. So if I highlight all these and hit Enter, well, the one that occurs most frequently is 68. But if you use MODE.MULTIPLE, when you highlight this, if there's a tie, bimodal or multimodal, it just spills all the modes it finds. And because we're in Microsoft 365, when I hit Enter, the results spill from the top cell. Remember, with spilled arrays, formula doesn't live below, only in the top cell. But now we're not going to get tricked with MODE.SNGL. We can clearly see there's two values, 68 and 76. Now, we could go through and manually count, but it would be really nice if the MODE.MULT function also told us the frequency. But it doesn't. But here's a great trick. And here's something important about dynamic spilled array formulas. Now notice that's grayed out. The formula only lives in the top cell. So if I want to move it, all I have to do is move the top cell, Control X. And when I Control V, because the formula only lives in the top cell, the whole spilled array is moved. Now let's add a new column here. Something like frequency. Add a little formatting. Format Painter from the mini toolbar. Click. And now I want to use the COUNTIFS function with an S. And I want to count how many 68s and 76s there are. Now, criteria range, that's all the data points. So I highlight everything here. And then I type a comma. Now, for criteria, I need 68 in this row to count how many 68s there are. And then down in the 76 row, I need the 76. Well, because this is a spilled array, watch what happens when I highlight both cells. It knows that the formula is only in the top cell, M20. That hashtag or pound symbol is the spilled range operator that will always allow the formula to get everything that spills from M20. Now, what that means is that COUNTIFS will be given two values. So when I close parentheses and hit Enter, it spills the results. That means there's a frequency count of 3 for both values. And importantly, because these are formulas, if I made a mistake with one of these values, that wasn't 78, it was 76. When I change it and hit Enter, instantly the results update. Control Z. Now, of course, we could have done this with a pivot table. But isn't that nice that if we're interested in the mode, it lists only the mode? Because in fact, if I make a pivot table, Alt-NVT, existing sheet, somewhere over here, click OK. When I drag test score down to rows, I get a unique list of values, but there's a lot of them, many more than I need. Drag test scores down to values, right-click, summarize values by, and count. Well, there I can see, well, there's the 3 and the 3. So I certainly could do it this way. But it's nice to have a formula that shows me just the mode values and the frequency. And of course, if we change 68 to 76 when I hit Enter, formulas instantly update. Pivot table requires a right-click refresh. And now we can see 4 and 2. Now I'm going to Control Z to undo the refresh, Control Z to undo that changed number. Now when we get categorical data, pivot tables are the easiest and fastest way to go. especially since it also gives us the total at the bottom. But if we have categorical data like this, there is a formula solution that we could build to build this frequency distribution. Now, the only reason that you'd want to do this is if you have a requirement for your project that requires when source data changes to have the report instantly update. Now, I added some labels at the top, and we're going to have two spilled formulas, one for the unique list and one for the frequency. For the unique list, we can use the amazing dynamic spilled array function sort. Inside the array, we have to actually create the unique list. So we use the unique function. Inside the array for unique, we highlight the values, and then close, close. And when I hit enter, a sorted unique list spills from that top cell. Now we can use this as the criteria for each row and use the COUNTIFS criteria range. That's all the values you potentially want to count, comma. Criteria 1, we want all 4 criteria, 1 for each row. The formula lives in G17. The spilled range operator, the pound or the hashtag, that says be sure and get everything that spills from that top cell. And because there's 4 items, when I close parentheses and hit enter, COUNTIFS spills the result. Now, we're not going to add a total row because that requires a very complicated formula. But there you go. We can clearly see that the mode is Blocksy. And because it's a formula, if I change some data, we'll change Blocksy to Coke and hit enter, instantly the results update. As you know, a pivot table requires a refresh. Now, it's not so hard to right-click refresh, and that total row is really nice. But if you need something like this to instantly update, that's how you do it. Now I'm going to Control-Z on the refresh, Control-Z on the data change. All right, so we learned about the mode calculation, which is a type of average commonly used on categorical data and also used on quantitative data. Now, we've seen 3 types of averages, mean, median, and mode. Now, those 3 measures of central tendency have an interesting relationship that we want to check out on the sheet Skew. Now, we already studied Skew when we looked at histograms. Here's an example of left or negative skew. The frequency for the small numbers is low, and the frequency for the larger numbers is high. When this happens, a few small values will tend to pull the mean down away from the median. When we have left or negative skew, the mean is usually less than the median. When we have right or positive skew, the frequency for the large numbers is low, and the frequency for the small numbers is high. A few big values tend to pull the mean up away from the median. When we have right or positive skew, the mean usually is greater than the median. Now, when we have no skew at all, a bell shape or symmetrical shape, then the mean and median are equal, and all 3, mean, median, and mode, tend to be right near the middle of the data set. Now, histograms give us the visual of the skew, but here's the math formula to actually calculate skew. Skew measures the shape of the data distribution. Skew tells us which way the distribution is tilting. You can think of skew as the tilt of the histogram. Now, we don't have to do this formula here, although it's possible in Excel, because in Excel, we have the skew function. Now, when we calculate skew, the result can be negative, skew to the left, positive, skew to the right, or 0, no skew at all. Now, let's scroll down. Now, we have 3 simple data sets to check this out. Now, I want to first count, and these are numbers, so we use the count function. And this is an aggregate calculation. And I'm going to highlight the range and leave it as a relative range because I'm going to copy it to the side. And by the way, when you have an aggregate function like this, you actually can't spill it directly. Because if you put everything in and expect it to spill, aggregate functions always deliver one answer. But no worries. In Excel, we put in these relative cell references, close parentheses, Control-Enter. And when we copy it to the side, go to the last cell and hit F2, we could see the relative cell references moved as we copied the formula. Now let's calculate the mean, average. And watch this. I'm going to calculate the average, enter, equals median, get that same range, enter, equals mode. And I'm hoping there's not multiple here. But I'm going to use multiple just in case because it'll spill and let me know. That's an aggregate calculation, so enter. And then equals skew. And here's our first example of a function that's different for the sample or the population. The bizarre thing is, though, is other functions that we use, like standard deviation, they'll have .s, meaning sample, or .p, meaning population, but not skew. They left the s out. So this one is for sample data. I'm going to highlight and then enter. And now, because all of these are relative cell references, I can highlight all four, click and drag to the side, go to the diagonally furthest one away, and hit the F2 key just to verify that the cell references are pointing to the right place. And they are. Now, if we look at our results, our measures, for this distribution here, we see a skew of minus 0.6. And that's a moderately negative skew. And that makes sense. We see that the mean is below the median. So it looks like a few small values are pulling the mean down away from the median. Here in this bell-shaped distribution, look at that. Mean, median, and mode are all equal. And skew is exactly 0. For this distribution, skew to the right, we see a few big values pulling the mean up. There it is, 14, bigger than the median of 9 and the mode of 7. And look at that. We get a skew value of positive 1.6. Now let's look at a few other examples on skew to the left. Here we see a distribution for test scores. There's a bunch of really big values and a few really small values. So this should be skew to the left. And when we measure it, we see skew of -2. So that's got some big skew to the left. Here's bimodal. That means we basically have two mountains of counts. And we can see the skew is almost 0. Now if we go over to skew bell shape, looks like this sample of human heights is not quite bell-shaped, but it's pretty close. So we get a small skew. If we go over to skew right, here we have some house price data. And sure enough, there's $2 million houses that are causing this to be skewed to the right. So we get a large positive skew of 1.5. Now on the sheet bonus V9, here are your 3 bonus tips, all about calculating the average, but with a real-world twist. Now, what about this situation? We want mean test score. We have test 1, test 2, 3, and 4. Well, the average function can do that. Average. And in number 1, instead of highlighting all of it, that would give us the wrong answer. We highlight just the first test, and then I type a comma. Then I see the next argument, number 2. I'll highlight test 2 and 3, comma. I see number 3. There's test 4. And now when I hit enter, there's the mean test score, 69. We can do the same thing for quizzes. Now, number 1, I see quiz 1, 2, and 3 are all next to each other. Now, as an alternative, instead of typing a comma to get to the next argument, you can just hold the Control key and highlight ranges that are not next to each other. Now, I'm holding Control. I'm still holding Control. And there you go. It put the commas in for me. When I hit Enter, now we have the mean quiz score of 5.55. Now we want to scroll over and go look at bonus number 2. And for bonus number 2, we need to learn about what a moving average is. And in fact, we're going to go to this government COVID data site and download a data file. So let's click this link to open it. It opens up this website. We want to scroll down. There's a chart. And below the chart, it says data table for daily cases. We want to click the plus. There's the table we want to download. Click download data. We definitely want to use Save As. So I'm going to click this if this pops up for you. Some of you, depending on your browser, will get Save As directly. This is a CSV file. You want to make sure and save it to the folder you created in Video 1 where it says your name. Click Save. Back here in our Excel file, I'm going to select cell R6. Go to the Data tab. This is our Power Query. We want From Text CSV. Click. In the Import dialog box, navigate to your name folder. Select the .csv file. Click Import. In the next dialog box, it shows the file name at the top. You want to make sure that the delimiter is a comma. And we can see a preview here. And by the way, your dates will be for some other month besides mine, and that's fine. Do not click Load. Click the Transform Data button. When I click Transform Data, it opens up the Power Query window. The first thing I want to do is rename it. So in Properties, I'm going to click in the Name text box, Control-A to select it all. Something like F Daily COVID Data. You can name it something different, but give it a name so it's easily recognizable, and Enter. Now, one thing different about this CSV file than earlier in the class is we have some rows at the top that we don't want, and the field names are in the third row. To get rid of the first two rows, go to Home, Reduce Rows, Remove Top Rows. I'll type 2, click OK. That adds a new step. We need to promote the headers from the first row. In the upper left corner, I click the drop down. Use first row as headers. That adds 2 new steps, promote and change data types. All we want is date and new cases. We're actually going to manually create this calculation here ourselves. To select these columns, click Date, hold Shift, click New Cases. Now we want to only keep these. So right-click one of the field names, right-click, remove other columns. That adds a new step. Now we want to go to the Home, Close, Close and Load dropdown, Close and Load To. In the Import Data dialog box, we want an Excel table. We want it on the existing sheet. Make sure it's R6. Click OK. Now the query, which is now an Excel table in the Excel worksheet, shows up in the Queries and Connections pane. There it is. If you don't see that pane, go to Data, Queries and Connections, and you click that button there. Now the nice thing about an Excel table is that when we create a column, it'll automatically be incorporated into the table, and our formulas will automatically copy down. Now, before we create a new field here for 7-day moving average, I want to use a line chart to plot December dates and new cases. And look at the chart and see how if we calculate the moving average, it'll actually help us to pick out the overall trend or pattern more easily than the individual numbers. Now let's highlight the field names. And for you, you're going to have different data here. But let's highlight about a month. Go up to Insert, over to Charts. We want the line chart, the first one. Move it to the side. Click on the title. Type an equal sign. That shoots me up to the formula bar. I'm just going to put the title, which is the web address of where I got the data. So the source data link, and Enter. Home ribbon tab. I think I'll change the font size to 10. Now notice there's no formatting here. But if we highlight the whole column, Control-Shift-Down arrow, and we can see there's about 700 rows, Control-Backspace, Control-1 to open up Format Cells. I want Number, use a decimal, 0 decimal places, click OK. So that formats the numbers there and in the chart. And now what we have is a line chart that shows us the volatility in number of cases per day. And that's useful information. But it would also be nice to have a line that more clearly shows the overall trend. And the way you do that is with moving averages. Moving averages can smooth out the volatility and better show you the trends and patterns. Now we need to add a new field to this Excel table. So to the right of the last column, we type a field name, and I'll call it 7-day moving average. Now this is an Excel table, so when we type a field name and hit Enter, instantly a new field is incorporated into the Excel table object. Now we can create our moving average formula using the average function. And in number 1, we're going to create a relative cell reference, a range. This row plus the 6 rows before. I'm watching the screen tip. When it gets to 7 rows by 1 column, I have my relative range of cells, which will always look at the current row and 6 below. Close parentheses. And this is an Excel table. So when you create a formula and hit Enter, it automatically copies down the column. It doesn't spill like a dynamic array formula because you can go to any cell and hit the F2 key. The formula is there, and you can see the beauty and simplicity of relative cell references. It definitely got this row and the 6 days before. Enter F2, enter F2. And as the formula copies down, you can see those relative cell reference help you understand why this is called a moving average. Because in every row, that range is moving, giving you the 7 previous days. And what we get is a column of smoothed out averages. So when we come over to our chart, right-click, select data. In the Select Data Source dialog box, series, those are the numbers. We want to add the series name. That'll be 7-day moving average. And then in the series values text box, make sure to highlight that =, curly bracket 1, and delete it. And now we want just the 7-day moving average for December. Click OK. Click OK. And just like that, we've plotted our 7-day moving average line to smooth out the daily volatile numbers. And we can more clearly and easily see the trends and patterns. Now, we definitely need to indicate what each of these lines mean. So we come up to the green plus, click, and I'm going to check legend. Select the legend, Control 1. And over here, I'm going to put this at the top. Now, I don't think I like that new cases. I'm going to change the field name to number of daily COVID cases and enter. And now we clearly can see the volatility in the daily cases and the 7-day moving average, which we often hear about in the news, smoothing out and giving us a better picture of the trends. Now let's scroll over because there's many uses for moving averages. Here we have a company, Boom Incorporated. Here's the date at the end of the month and their sales. And we want to plot this, but we definitely want a smooth trend line showing us the 6-month moving average. So average, and I'll go down 6 rows. And this is not an Excel table. It's not a spilled array, so I have to enter it. And I'm going to Control Enter. And I'm not going to double-click and send it down. I'm going to manually copy it with my crosshair and angry rabbit because I don't want to go all the way down, just down to June 30th. Now I can highlight the field names at the top, down to June 20th. Insert. We'll put a line chart. Move it to the side. And for the chart title, =, click on AC2 and enter. And now the company definitely can see the up and down volatility of sales. But importantly, it can see the trend. Looks like it was going up for about a year, then down. And over the last few months, it looks like a sharp trend upwards. All right, that was a lot of fun with measures of central tendency. We saw, importantly, moving averages both for sales and COVID-19 data. We also saw, again, how to use Power Query to get and transform and clean the data before we make our visualization. We saw how to enter multiple ranges for an aggregate calculation. And then over on Skew, we talked about Skew both in a histogram and in our lovely math formula. We talked about the mode calculation with various methods for categorical and quantitative data. We talked about the median, which is important when you have extreme values, and the median will mark the center position of the data set. We talked about the mean calculation, add them up, divide by the count. Great when we don't have extreme values. We talked about some notation here for x bar, that's the mean of a sample, and mu, the mean of the population. And we started it off by talking about location. All right, next 2 videos, we'll have 2 more measures for central tendency. We'll have the amazing weighted mean and the financially helpful geometric mean. All right, we'll see you next 2 videos.